problem, which we have 3 to the power x minus 2 to the power x, which is equals to 65. This is exponential equation here, which we have. It is easy to solve by assumption, but we are not here for assumption. Let's try to see by assumption. By assumption, we can plug any number. We can try error here in these powers which we have. We can say by assumption. Let's say assumption. By assumption, we can say 3 power 4 minus 2 power 4 should be equals to 65, right? Then 3 to the power 4, it is 81. Then minus 2 to the power 4, it is 16. Then when you subtract 81 minus 16, it is 65. But for today's video, we are not here for assumption. We have to find how we can find this 4, which we have just introduced for try and error. So now let's try to see how we can find this 4. Let's get started. For solution, we have 3 power x minus 2 power x should be equals to 65, right? We can take these values into brackets, so we can say 3 power x minus 2 power x should be equals to 65. Then here we can say there are numbers which are invisible here, which we can say power 1, power 1, because 3 to the power x power 1, it is same as 3 power x, right? Then even here, 2 to the power x to the power 1, it is equals to same, which is 2 power x. So now, let's say, for us to find this one, we can get any number. It can be 1 into 1, it is 1. So let's take 2. So we can say 2 divided by 2, it is 1. So we are going to take these numbers which we have here, this fraction. So we can say 3 power x, then to the power 2 power 2, right? 2 to the power 2 over 2, then minus 2 to the power x, then 2 over 2, right? Which is equals to 65, right? I hope you're following. Then here 3 to the power x to the power 2 over 2, we can say it is, let's take it here, 3 power x power, we can take it as 1 over 2 multiplied by 2, because 1 over 2 multiplied by 2, it is same as 2 over 2, right? And minus, we can do the same even here, 2 to the power x power 2, let's say half multiplied by 2, right? Which should be equals to 65, right? Then here, x times the half, you are going to have, let's say in indices, whenever you're having a to the power r, the power n should be equals to, you multiply the powers, you are going to have a r power n, right? So we're going to do the same here, right? So we're going to see 3 power x over 2, right, in the bracket, then power 2, which are these 2 which is remaining here, then minus, even here you are going to do the same, which is 2 to the power x over 2 to the power 2, which should be equals to 65, right? Then here we can say let's 3 power x over 2 to be equals to b, and this one, the second term, which is 2 power x over 2 to be equals to b, a. So we have to substitute with these values which we have here. So we can say here we are going to have b squared, right? Then minus a squared, which should be equals to 65, right? Then if you reach here now, this one b squared minus a squared is a different of two squares, in which we are going to say we have b plus a, then a minus b. Oh, let me say here we have b minus b minus a to be equals to 65. We can break it into two parts. We can say 18 times 5, right? Then now if you reach here, this is where now you this this first term here which we have b plus a should be equals to 13, and this second term here b minus a should be equals to 5. So we're going to say b plus a to be equals to 13, right? Then b minus a should be equals to 5, right? In which this is a simultaneous equation in which we can add here. When you add here a, it will be let's say a, we can cancel this one, we remain with b plus b, which is 2b, which should be equals to 18. 13 plus 5, you are going to have 18, right? Then you take it here, 2b equals 18. Then you divide by 2 by 2. Then b, it will be equals to 9, right? Then let's find the a now. We can take any equation, even the first equation here. We have b plus a to be equals to 18, right? A, we have found that it is b, we have found that it is 9 plus a, which should be equals to 13, right? Then a, when you subtract 9 both sides, you're going to have 13 minus 9. Then a, it will be equals to 4, right? A, it will be equals to 4. Now we have found the values for, let's try to create a space here. We have found that b, it is equals to 9, and a, it is equals to 4, right? Then remember, we said let's 3 to the power x over 2 to be equals to b, and 2 to the power x over 2 to be equals to a. So we have to substitute now. Here we have a 9, right? We have a 9. So in which it will be 3 to the power x over 2 to be equals to b, we have 9, right? Then we can reduce this one to have the same base, so in which it will be 3 to the power x over 2 to be equals to 3 power 2, right? These bases are same, so we can only take the power. So we say x over 2 to be equals to 2. Then here you cross multiply. Then the answer you are going to get, it is 2 times 2, which is x equals 4. So you are going to get the same answer even if you equate this equation to be equals to. Let's try to equate now for a. For a, we have found that it is 4, right? So we're going to say 2 to the power x over 2 to be equals to 4. We are going to do the same thing even here. We equate this equation to have the same base. So we can say 2 to the power x over 2 equals to 2 power 2, right? Then these bases are same, so we're going to only correct the powers. So x over 2 equals 2, right, over 1. Then you cross multiply, you're going to get x equals 4. So the value of 4 the value of this exponential equation, it is 4. Like I say, for assumption, we find it was 4. But going down, finding the solution on how we can find that for which we did the assumption here, we have arrived that x it is equals to 4. Thank you for watching, and don't forget subscribe and turn on the notification bell so the next time you may see the new update. The next lesson will be looking at other exponential equation. And don't forget to check those upcoming videos there. Thank you. All right.